When you look up on a clear night, the sky feels peaceful, a quiet, twinkling canopy. But that tranquility is a biological illusion. Human eyes are incredibly limited instruments, evolved to process only a microscopic sliver of the electromagnetic spectrum, what we call visible light. Our bodies are just as fragile as our eyes. To survive the microgravity of low Earth orbit, astronauts have to undergo grueling preparation, simulating the sheer physical strain and deep isolation of space inside massive underwater facilities like NASA's Neutral Buoyancy Laboratory. Since our biology keeps us tethered close to home and our eyes are blind to most of the cosmos, we have to build mechanical eyes to do the exploring for us. We construct sensors designed specifically to catch the invisible wavelengths raining down on Earth, like infrared heat and high-energy gamma rays. Catching that ancient invisible light requires engineering on a massive scale. To see the faintest heat signatures from the early universe, scientists built the James Webb Space Telescope with 18 golden hexagons forming a primary mirror over 21 feet across. Stepping outside our biological limits reveals a cosmos teeming with hidden activity. The dark spaces between the stars are actually filled with the violent engines of the high-energy universe, structures we are only just beginning to map. Take a nebula. In visible light, these giant clouds of interstellar gas look like serene, glowing mist floating in the dark. But when we switch our sensors to the infrared spectrum, that peaceful facade drops, revealing intensely active stellar nurseries. Inside these towering columns of dust and gas, gravity is going to work. It compresses immense pockets of material until the temperature and pressure become so extreme that nuclear fusion ignites, birthing entirely new stars in the dark. And we also see the opposite end of that life cycle. When a massive star runs out of fuel, it collapses and detonates in a supernova, leaving behind sprawling graveyards of superheated plasma and expanding webs of debris. Matter is locked in an endless cycle of birth and detonation. It's an engine of creation and destruction, operating on a scale of millions of years, completely hidden from the naked human eye. Zoom out from individual stars and you hit the scale of galaxies. They generally fall into three categories: organized spinning spirals like our Milky Way, older dead red ellipticals, and chaotic irregular galaxies, the mangled wreckage of cosmic collisions. But when astronomers measure the visible mass in these spinning galaxies, there is a glaring physical anomaly. Based on the stars and gas we can actually see, these structures are rotating so fast that they should fling themselves apart. To understand why they don't, we have to look at Albert Einstein's general theory of relativity. Through tensor equations mapped out over a century ago, Einstein proposed that massive objects don't just pull on each other, they physically warp the actual fabric of spacetime. In gravitational lensing, we watch light rays bending in curved arcs around a massive obstruction. By measuring this bend, scientists proved an enormous unseen mass exists. This invisible scaffolding is dark matter, the heavy skeleton holding galaxies together. The stars, the planets, the glowing gas, everything we can physically interact with is just a superficial dusting of frosting. The bulk of the universe is built and ruled entirely by invisible forces. If you follow that rule of gravity to its most terrifying extreme, you arrive at the absolute limit of physics, the black hole. Looking at this image of the M87 supermassive black hole, we can see the anatomy of this extreme environment. That glowing orange ring is the accretion disk, a whirlpool of superheated gas burning intensely from friction as it spins faster toward the center. The dark center within that ring is bounded by the event horizon. This is the absolute point of no return. Here, the mass is so dense and space-time is so severely warped that the velocity required to escape exceeds the speed of light. Once material crosses that threshold, it descends toward the singularity. At this microscopic point, physics breaks down, and light instantly vanishes into the void. Because nothing that passes this boundary can ever reach an outside observer, black holes act as the universe's ultimate traps. They are regions where both matter and energy are permanently walled off from the visible history of the cosmos. Knowing how hostile the physics of the universe can be, astrobiologists are actively searching this violent landscape for any company. They scan the atmospheres of exoplanets for chemical biosignatures, like oxygen, and listen for technosignatures that would prove the existence of intelligent alien life. We have even tried to bridge the void ourselves. We attached physical records of our existence, like the engraved golden surface of the Voyager Golden Record, to deep space probes, hoping someone, eventually, might find an answer. But after decades of pointing our radio telescopes at the spiral arms of our galaxy and analyzing thousands of exoplanets, the result is terrifying. Absolute, deafening silence. This contradiction between the high probability of extraterrestrial life and the total lack of evidence is known as the Fermi paradox. One proposed solution is the Great Filter. The theory suggests there is a universal, catastrophic hurdle, some biological or technological barrier, that causes civilizations to abruptly halt and destroy themselves before they can expand across the stars. The dark universe is filled with sterilizing radiation, crushing gravity, and an unsettling cosmic silence. Against that backdrop of extreme hostility, Earth's solitary spark of life is infinitely precious, desperately isolated, and deeply urgent to protect.